Assalamualaikum warahmatullahi wabarakatuh. My name is NURAINA binti Burhanudin. My matric number is B122310085. Today will present to you our assignment, comparative analysis of EDFA and SOA in long haul optical communication system. And this is our group member, which is me and Nur AQILLA binti AMINULLAH, Nur ALIA binti AMIR, and NURUL Aina IZZATI binti ROSLI. Introduction of this assignment is optical communication is widely used in modern telecommunication networks because it can transmit large amount of data at high speed. Second, optical signal become weaker as they travel through optical fiber over long distances due to the attenuation. To overcome this problem, optical amplifiers are used to increase signal power without converting the signal into electrical form. EDFA and SOA are two commonly used optical amplifiers in modern optical networks. And this assignment compare the performance of EDFA and SOA in long-haul communication system. Firstly, it was EDFA, which is erbium doped fiber amplifier. EDFA is an optical amplifier that uses erbium doped fiber as the gain medium. It amplifies optical signals directly without converting them into electrical signals. Upon laser excites the erbium ions inside the fiber, causing stimulated emissions to occur. And this process increases the signal power and compensates for transmission losses, which is EDFA is widely used in long-haul optical communication system due to its high gain and low noise characteristic. And the advantages for this EDFA is which is one, high gain. Second is low noise figure and suitable for long distance transmission. Next is semiconductor optical amplifier, which is SOA. SOA is an optical amplifier that uses semiconductor material as the gain medium. It operates similarly to a laser diode and amplifies signal through stimulated emissions. And when an optical signal enters the active region, the signal is amplified directly in the optical domain. And SOA has a compact size and can be easily integrated into photonic devices. And it is commonly used in metro network and optical switching application. And the advantages for this SOA is compact size. Second is fast response time and wide bandwidth and easy integration. This slide shows the comparison between EDFA versus SOA. First, in terms of gain medium, EDFA uses erbium doped fiber while SOA uses semiconductor material. For gain performance, EDFA provides higher gain, typically between 20 to 40 dB, whereas SOA provides moderate gain around 20 to 30 dB. And in terms of noise figure, DFA produces lower noise, resulting in better signal quality at the receiver. However, SOA has the advantage of being more compact and having a faster response time. Looking at the cost, SOA is generally less expensive than EDFA. EDFA is more suitable for long-haul optical communication system where high signal quality is required, while SOA is more suitable for metro and access network where compact size and lower cost are important.
Assalamualaikum, my name is Nur AQILLA binti AMINULLAH and my matrix number is B122310215. So I will explain about the simulation. So this is the picture of the simulation. I'm using the Optic system. For transmitter, generates an optical signal at 1550 nm using a CW laser and an external Mach-Zehnder modulator. Then signal splitting. 1 times 2 fork splits the signal into 2 identical paths to ensure a fair test. And then fiber medium. Both channels transmit through an identical 50 km optical fiber, 0.2 dB per km loss, 16.75 ps over nm over km dispersion. And then the comparison amplifiers. Top path uses a standard optical amplifier, 10 dBm power, 4 dB noise figure. And then for bottom path uses a semiconductor optical amplifier, SOA, driven by a 0.15A current. And then lastly is receiver and analysis. Both paths use a pin photodetector, a Bessel filter, and a 3R regenerator to feed into a BER analyzer to compare final signal quality.
Hi, my name is NURAINA IZZATI binti ROSLI. My matrix number is B122310189. Now, I will explain about result and discussion. This section compares the performance of EDFA and SOA amplifier in a 50 km optical fiber communication system. Both amplifiers were used to compensate for signal attenuation caused by fiber transmission. The performance was evaluated using the BER analyzer, focusing on the Q factor, BER, and I diagram quality. For this figure, show the BER analyzer result for the EDFA amplifier. The EDFA was configured with a gain of 10 dB and a noise figure of 4 dB. The eye diagram exhibits a larger eye opening by less distortion, indicating better signal quality. The Q factor is greater than 6, which reflects excellent signal performance and a very low probability of bit errors. The low BR and high Q factor demonstrate that the EDFA effectively amplifies the optical signal while maintaining its quality. The superior performance is due to its high gain and low noise characteristic. Next, this is the result of SOA amplifier operating at an injection current of 0.15 ampere. Although the SOA successfully amplifies the attenuated signal after 50 km transmission, the eye diagram showed a smaller eye opening and greater distortion compared to the EDFA. The Q factor is below 6, while the BER is higher, indicating degraded signal quality. This reduction in performance is mainly caused by amplified spontaneous emission, noise gain, saturation, and non-linear effect within the SOA. Overall, both amplifiers successfully compensate for fiber losses and enable signal recovery at the receiver. However, the EDFA achieved below performance in terms of Q factor, BER, and eye diagram quality. Therefore, EDFA is more suitable for long-distance optical communication system where high transmission quality is required. In contrast, SOA remains a practical solution for short-distance optical network and photonic integrated circuit due to its compact size and lower cost.
Assalamualaikum, my name is AFIFAH ALIA binti MOHAMAD. I would like to present about the safety, legal, social and environment issues in comparative analysis of erbium doped fiber amplifier EDFA and a semiconductor optical amplifier SOA in long-haul optical telecommunication systems. Besides technical performance, several non-technical factors should be considered. The safety issue include laser exposure that may damage eyes and injuries caused by fiber fragments, which can cause skin and eye injuries. So it would be proper to use safety glasses and good handling procedure. Next, about legal issues part, there have been considerations involve compliance with telecommunication regulations, protection of user data and privacy, and use licensed software and proper citations. From a social perspective, optical communication improve access to education, which is online learning, and remote work, which can improve communication and healthcare access and helps reduce the digital service. Environmentally, fiber optic systems are energy efficient with lower power consumption than traditional systems, which support sustainable communication infrastructure and use proper disposal and recycling of electronic equipment. In conclusion, EDFA and SOA were successfully compared using optic system simulation. Both amplifiers provide signal transmission in long-haul optical communication systems. Based on the simulation results, EDFA generally achieve better performance in terms of Q factor and BER, while SOA offers advantage such as compact size and easier integration. Therefore, the choice of amplifier depends on the specific requirement of the communication system. That's all from our group. Thank you.